Hello everyone, welcome back to our channel. Today we are going to discuss about very short answer questions from the ray optics. From this, one v.s.a.q is compulsory coming for board examination. What is the ray optics? In this chapter we are discussing about the straight line path of that ray or light ray. How we can able to see the things when the light falls on the object because of the scattering of that light rays is reached to the retina. Then we can able to say that this object is here, that object is here. Because of that we can able to see the objects. Anyway, in this class our focus is on first very short answer question. What is the focal length and what is the radius of curvature? What is the focal length and what is the radius of curvature? What is the focal length? Suppose we are taking one concave mirror. Concave mirror. When the mirror means that reflections takes place inner side. When the light falls on this is the principal axis. This is the optic center of this one. Focal length means the distance between optic center of this concave mirror where that all light rays are focusing after reflection. That distance, suppose we are taking capital F and this is the focal length. The distance between optic center of this concave mirror when the all light rays are focused at single point, this distance is called the focal length. Then radius of curvature. When you cut this one, we are getting this concave mirror. When you should complete this one, this radius of curvature of this part is called the, this radius is called the radius of curvature. When you can complete, you should get one spherical or a circle shape where that radius, that is called the radius of curvature. Then our second question is, what do you understand that focus and what do you understand that principal focus? Suppose we are placing one object, in same case we are taking, placing at infinite distance where that all rays are focused at that point after reflection. Suppose some rays are coming and passing like this after reflection, that all rays are focused at a single point. That point is called the principal focus. Just now we know that what is the focal length means the distance between optic center and principal focus. So and that point is called the principal focus. In this case only, what is the principal focus? What is the principal focus? Suppose we are taking, this is the concave mirror, this is the principal axis and this is the optic center. If the rays are passing parallel to this one, means after reflection, these are focusing at a single point. If these rays are parallel to this principal axis after reflection, where these are coincide, this is called the principal focus. Even you are placing at infinite distance, all rays are focused and that is called what? Focus. But principal focus means incident rays are parallel to the principal axis and after reflection these are focused at a single point, that is called the principal focus. Then our third very short answer question is, what is the optical density and what is the mass density? What is optical density? See, we are taking air. When the light is traveling into the air, that velocity we know that 3 into 10 to the power of 8 meters per second. When we are going through the water, glass and that one, the density is more. So when this light ray is in vacuum, that velocity is different. Whenever it is passing through the or propagating through the any another medium, that velocity is reducing. Why? Because of the nature of the material, that velocity is reducing. And here one more thing, based on the refractive index, more refractive index, less velocity, that is called the optical density. But mass density is mass per unit volume, is called the mass density. So that is the third very short answer questions. Then our fourth one is, what are the laws of the reflection? So if angle of incidence, we are taking one medium, this is the normal to the surface, and light falls on this, it will make an angle with normal eye. And when it is going into the same reflection we are taking here, this is the angle of reflection. If the angle of incidence is equals to angle of reflection, that is called one of the laws of the reflection. Then second one is incident ray, normal and reflected ray. All three are in the same plane. That is, those are the laws of the reflection. Two we should focus, angle of incidence equals to angle of reflection. Then second one is incident ray, normal to the surface and reflected ray. All three are in the same plane. That is the second law of this one. Then fifth one is What is the optical power? Simply we can say that reciprocal of focal length is called the optical power, and unit also we should write it diopter. Diopter is the unit for this, otherwise we can say meter inverse also. Our next very short answer question is, they have given one concave mirror. This is the concave mirror. Focal length also they have mentioned that is the 10 centimeters. That is the 10 centimeters. And they are taking one wall. On the wall they are observing that image. That image distance they have given 35 centimeters. In problem they have given focal length is the 10 centimeters. That image distance is the 35 centimeters. We can find out the object distance, not from the optic center, from the wall, how much object distance is there. But anyway, clearly they mention that this is the concave mirror, means this focal length we are taking negative sign 10 centimeters. Then image distance is also minus 35 centimeters. From the mirror equation, what is that? 1 by f equals to 1 by v plus 1 by u. But we want the object distance, means 1 by u equals to 1 by f minus 1 by v. So instead of f minus 10 centimeters, anyway this is minus, means minus into minus plus 1 by 35. After taking the LCM and doing the simplification, we are getting u equals to minus 14 centimeters. U equals to minus 14 centimeters from the optic center. But the question is, from the wall, how much distance is there? Already we know that total distance is the 35 centimeters, means from the wall object distance is 35 minus 14 is the 21 centimeters. Then our next very short answer question also belongs to concave mirror only. But the thing is, image distance is equals to object distance. They mentioned that is 40 centimeters. So this is concave mirror, means we are taking here also minus. In this case, image, focal length and object all are at same side, means we are taking opposite to incident rays. So according to sign convention, we are taking the negative. As usual, we are using the mirror equation 1 by f equals to 1 by v plus 1 by u. So 1 by f, instead of image distance we are writing minus 40, and this is also minus 40. After simplification, that focal length is minus 20 centimeters. Then 8th question is, they have given angle of the prism is 4 degrees centigrade, 4 degrees sorry. Then angle of minimum deviation is 2.48 degrees. Find the refractive index. When we are looking this one, this angle of prism is very small. Generally, what is the formula for refractive index? Mu equals to sine a plus del dm by 2 divided by sine a by 2. When small angle prisms, no need of taking the sine, simply we can take it a plus minimum deviation by 2 divided by a by 2. These 2 to cancel. And instead of angle of the prism, we are taking 4 plus 2.48 by how much? 4. After simplification, 6.48 by 4 means we are getting 1.6. 1.6. So refractive index of the prism is 1.6. So no need of using the sign if the prism is small angle prism. Then our next question is, 9th question is, what is the dispersion? What is the dispersion? When light falls on the prism, then what happens? Light is the combination of the colors. So, and more than 2 colors, also composite colors also we can say that. When light falls on the prism, it is splitting into 7 colors with GR. So, then what do you say? This process or this phenomena is called the dispersion. Splitting of the light when it falls on the surface of the prism, that is called the dispersion. 10th very short answer question is, they have given that concave lens and image distance and object distance. They have given that relation, image distance equals to 1 by 10 times of that object distance. But convex lens, we should remember that focal length is, we should take minus, so minus 30 centimeters. In problem they mention that 30 centimeters. Whenever they will mention convex lens, means we can take it f equals to concave lens, sorry, f equals to minus 30 centimeters. Find the object distance. Here we can use the lens formula. 1 by f equals to 1 by v minus 1 by u. Instead of v, we are taking u by 10. After simplification, 10 minus 1 into 1 by u. Anyway, we want u means u equals to minus 9 into 30 equals to minus 270 centimeters. Then our 11th question is what is myopia and what is hypermetropia. Then 12th one. First of all, we are concentrating what is the myopia. So some people we are facing that sight problem. One is the short sight and another one is the long sight. Because of these defects only we are facing that one. What is the myopia? When light rays are coming, when they are focusing on our retina, there is no sight. If that is focusing in front of the retina, that problem is called the myopia. With the help of the concave lenses, we can rectify that one. Like that, what is the hypermetropia? And here light rays are focusing behind the retina. That problem is called the hypermetropia. With the help of convex lenses, we can rectify that one. Thank you.